Hey everyone. Sorry it's been a while since my last post. My last post was just before the day that we found out that we will not be returning back to school, and I'm not going to lie to you, I took it kind of like a punch in the gut. It's really difficult for me to think about the fact that I will not have any of you in my classes again. And I was very, very sad and disappointed, and I'm sorry that this has happened to your school year. And I just want you all to know that I miss you all very much. I miss seeing your faces every day, and I really had a great time with all of you in my classes this year. And I hope that you have a wonderful break, including your summer, and I hope that some of you at least will choose to come back and see me once in a while next year when I see you. So, in any case, I am going to go ahead and push forward. I didn't see any questions posted by anybody for the study guide that we just finished, so that was the end of the unit. So I'm going to go ahead and start putting some stuff out there over the next unit we would have done. That's just chemical reactions. And hopefully at least some of you choose to take advantage of it, because it's actually pretty cool and pretty fun. So for chemical reactions, it's just the process by which one or more substances are rearranged to form different ones. And so just as a review, I went ahead and put in this video evidence that a chemical reaction may have occurred. We talked about this throughout the year already when we were all together. Things that we have seen that indicated a chemical reaction were a change in temperature, change in color, some sort of odor was produced, some gas bubbles or fizzing, and then the appearance of a solid when we saw those two clear liquids mixed together and all of a sudden you saw a white powder. So appearance of a solid would definitely indicate what's called a precipitate, which we've talked about several times. So a solid that appears out of two different liquids. So when you're representing a chemical reaction, we're going to use something that chemists call an equation, where your reactants are the starting substances and the products are the substances forming the reaction. So when you write a chemical reaction like this one, what that's telling you is that the starting substances, or these, everything on the left-hand side of the arrow, are your reactants, while the substances forming the reaction, or these, which are on the right-hand side of your reaction, are your products. And then this table right here summarizes the symbols that are used in an equation, and pretty much up until this point right here, everything's pretty standard, but everything below that is probably new to you guys, so I would probably take special note of that. The S in parentheses, the L, and the G indicate the state of matter that the reactant or product is in, and then we've mentioned this a little bit, but wouldn't be surprised if you didn't remember it. But AQ means that it is a water solution, so something is dissolved in water. So now comes the part where we kind of put everything together. Everything that we learned so far this year, we start to put it all together into making a chemical reaction. So when you read something in a word equation form, like aluminum solid plus bromine liquid produces aluminum bromide solid. So what I just did was what's in quotation marks right there. It kind of translates to solid aluminum and liquid bromine react to produce solid aluminum bromide. And so the first step in writing any chemical reaction is what's called a skeleton equation, which is going to use symbols and formulas to represent reactants and products. And if the information is available, we're going to go ahead and include that information on state of matter, which is shown right there. The thing is, skeleton equations are just a starting point. They lack critical information that has to be included in a final chemical reaction, but they are the starting point. And since they are the starting point, that's all I'm going to be discussing for the rest of this video, is just getting your skeleton equation together. And I'm going to show you several examples of that here on the next few slides. So we'll say that we need to write the chemical reaction regarding this sentence right here. Magnesium metal reacts with oxygen gas to produce solid magnesium oxide. So we have to use everything that we've learned in the past. So we're going to be translating names into formulas, which we've been doing the entire time. And then we just have to put in those symbols that we discussed on that previous slide. So I'll show you what I mean. So step 1, it says magnesium metal, which means it's just magnesium by itself. And since it's a metal, that means that it is in solid form. Reacts with tells you that you have a plus sign at that point. And then it says oxygen gas, and oxygen is one of those diatomic molecules that I said would be a pain in the butt when you write chemical reactions, because you have to remember to always include that little 2 with it because it's diatomic. But it says oxygen gas, so I would go ahead and put my little G. And then to produce translates to my arrow. And then solid magnesium oxide. So magnesium oxide, I see that that is a ionic compound. So that means that I have to balance the charges. This is a metal, that's how I know it's ionic. And magnesium is a +2 and oxygen is a -2. So they go together without any subscripts. So MgO. And this right here would be my skeleton equation, which is what we are practicing today. So that is your goal, being able to translate these words in the word equation into an actual skeleton equation. All right. Here is our next example problem. I'm going to pause the video in just a minute so that you can give it a try on your own, hopefully. But then I'll show the answer here in just a minute. Okay, so sulfur dioxide, it has the prefix right there, so that's telling me the equation that I need to write down. So sulfur and then dioxide means there's 2, and then it says that it is gas, so it has to be like that. Okay, so we've got that much done. Reacts with gives me my plus sign, so that's done. Now water vapor is our next one, so water is easy enough. H2O, but since it says it's in vapor form, that means it has to be a gas. So we're done with that. To produce tells us time for the arrow, so done with that part. And then aqueous sulfurous acid. And okay, we named acids before we left for this craziness. So the ending OUS tells us that we're looking for a polyatomic ion with the ending ITE, which means we're looking for sulfite. And sulfite looks like this, SO3, which has a 2- charge, so we need 2 hydrogens to go with it. And it's aqueous, so we have to include the AQ. So there's your skeleton equation. Okay, here's your next example problem. Take a minute or two and give it a try, and then I'll show you the answer in just a moment. So this one was a little trickier, and I kind of broke it up into the pieces so you could kind of see my thought process. Calcium carbonate, I have a metal there, so that told me it was ionic, so I went and looked at my charges. They balance out, so no subscripts were needed for calcium carbonate. It's a solid. And then, so that covered that part. And then reacts to form. The to form told me that it was arrow time. And then solid calcium oxide. Calcium's a metal once again, so it was ionic. So I balanced my charges, +2, -2, which means no subscripts were needed. And it was a solid, so that took care of that. And then it says and, which told me my plus sign. And then carbon dioxide. The prefix tells me what to write, carbon and then 2 oxygens, so that took care of that, and then it was a gas. So that's my entire thought process for writing it, and hopefully you're doing well. On to the next. Okay, so here is our last example problem. I'm going to give you a little break here to try it on your own, and then I'll show you the answer. Okay, and here you have it. This is what this skeleton equation should look like. I'm going to give you a little bit more practice on Wednesday of this week. And then we'll be moving on to the next step in writing equations probably on Friday. So please stick with it, guys. It'll do you a lot of good, especially if you get to college, even if you have to just get through chemistry to do whatever you're doing. This will help you a lot. So I hope that you'll stick with it, and I miss you guys, and I just hope you stay well and have a great break.